Welcome to the fourth video of System Programming and Compiler Construction. Let's continue with the first module, that is Introduction to System Software. Till now, we have completed the topics that are marked in red. In today's video, we will be looking more about loaders, then we'll see what are compilers, what are interpreters, and how a C program is compiled. What is relocation in system programming? So this relocation word was used by me when I was explaining assembler. So when I explained assembler, I said that the assembler is responsible for taking assembly language as input and converting it into relocatable machine code. So what is this relocation all about? Ideally, when a C program is successfully compiled, it is then submitted to the assembler. The assembler is then responsible for assigning relative addresses to all the instructions and variables which are there in the program. What do you mean by the term relative? Relative means the assembler identifies one memory location as its starting address or base address. Considering the base address, it will start giving addresses to the instructions and the variables. Then the assembler will give me my object code. So in short, the object code or the machine code will have the memory locations where the instructions will be saved or where the variables will be saved in the main memory. Now when the loader takes this program, it first checks whether the assigned memory are available or not. If the assigned memories are available, then the program is just allocated to that memory. But if the memories which are used are not available because the operating system is using those locations for some other task, that time the loader is responsible for identifying locations or for identifying memory locations which are available at that time. Thus, the loader has to now allocate this program to a different memory locations. Hence, the concept is known as relocation. Let's see what is written on the slide. Sometimes a programmer may code a program with the intention of executing the program from a specific area of memory. This program which is mentioned on the slide is nothing but my assembly program, because it is the assembly program which provides memory locations to various instructions and variables. But it may happen that the operating system may occupy the same specific area of memory for some other purpose. In such case, the loader has to allocate a different memory area to the program for its execution. When loader is doing this, when loader is allocating a different memory area to the program, you call that concept as relocation. In short, relocation is a process where the loader changes the memory addresses mentioned in the program with the available memory address so that the program can correctly execute in the allocated area. Continuing with the functions of the loader, a loader typically performs 4 key functions, each critical to the process of program execution. The functions that the loader is supposed to carry out is allocation, linking, relocation, and loading. So what is allocation? Ideally, in my previous slide, I have said that the linker is responsible for combining all the object file into a single object file, and this object file is having an extension exe. The linker, when creates this exe file, it stores this exe file on the hard disk. The loader then identifies, or the loader looks at that exe file and identifies what is the size of that exe file. Whatever is the size of that exe file, that much amount of memory is looked upon by loader into the main memory, or that much amount of space is looked upon by the loader in the main memory. When the loader takes up that file from the hard disk and loads it into the main memory, this process is known as allocation. Let's see what the slide says. In order to allocate memory to the program, the loader allocates the memory on the basis of the size of the program. So as I said, the loader finds out what is the size of the exe file which is kept on the hard disk. Based on that size, the loader will identify that much amount of space in the main memory, and then the program will be loaded into that area for its further execution. Next function is linking. So linking is the process by which linker will combine all the multiple object files and it will resolve the symbolic references to produce a single executable program. Relocation, as I've already explained in the previous slide, relocation is, or you can say, there are some address dependent locations in the program. So as I said, the relative addresses are nothing but the address dependent locations, and these address constants must be modified to fit the available space. So these addresses are modified only if those mentioned spaces are not available. Then the loader finds out some new place. When it is finding out a new place and is using that new place for the program to be loaded, that concept is known as relocation. Lastly, loading. The loader loads the program into the main memory for execution of that program. It loads machine instructions and data of related programs and the subroutines into the main memory. This process is known as loading. The loader performs loading, hence the assembler must provide the loader with the object program. Coming to next, so these are the differentiating points between linker and loader. For your reference, I have taken this screenshot from Geeks for Geeks. You can expect a 5-mark question on how a loader is different from a linker, or what are the differentiating points between loader and linker. The next system program that we are learning is compiler and interpreter. As the slide says, a compiler converts the whole source code to object code, while an interpreter transforms and runs the source code line by line. I assume that whoever is listening to me must have worked with C programming, and you all might have worked obviously with Python also. Whenever we write a C program, we never come to know whether we are doing any mistakes while writing the program. But on the other hand, whenever a program is written in Python, as my first line is completed, the Python interpreter immediately will tell me whether that line has error or not. So in my C program, if I want to check that whether I have made any mistake, I need to submit my entire program to the compiler. Now the compiler will be compiling my source code or will be converting my program to assembly program. If there is no error, then the compilation will happen successfully. But in case of error, the compiler will list down all the errors along with the line number. It becomes very tedious for a programmer to go to every line and to rectify the errors. As a programmer, you must have noticed that sometimes a single mistake in my program can lead to more than 3-4 errors. So what we have to do is, we need to compile our program, go to the line where the error is, correct that error, and then again compile. So this task has to be done again and again until the compilation is not done successfully. Whereas an interpreter will immediately tell me whether I have made any mistake. So an interpreter basically transforms or converts every code into its object code line by line. Let's see what the slide says. A compiler is defined as a software that transforms an entire set of source code into object code and saves it as a file before executing it. So, after the successful compilation of program, the object code is saved in a file, and this file has an extension .obj. As an intermediate phase, certain compilers transform the high-level programming language into assembly language, and there are some compilers which skips this intermediate step and directly converts high-level program into machine code. This conversion of source code into machine code is called compilation. Popular computer languages that use compilers include C, C++, COBOL, and Fortran. Coming to interpreter. Interpreter is a software that executes the line-by-line conversion of high-level instructions into machine-level programming. As I said, errors are displayed line by line, making the correction of them simpler. If you compare this with C program, you must have observed, you must have noticed that every time an error is identified, you need to change that one error, compile the program, check if errors are existing. But with Python, this task is simplified. It helps the programmer in identifying errors and correcting them before moving on to the next statement. Source code lines are compiled beforehand and preserved as machine-independent codes, and this is subsequently attached at runtime and processed by the interpreter. The most prominent programming language which uses an interpreter is Python. These are the differentiating points between compiler and interpreter. Again, this is an important question from examination point of view. You can expect a 5-mark question on the same. Okay. The last system program that we will be taking is editors. For everybody's note, I have highlighted some topics in green. These topics, since are already done in the subject of operating system, I request you all to please do it as self-study. But in case if you want me to create a video on the marked topics, then you can please comment down. I will create a video on the topics that are marked in green. Let us understand what are editors. Editors are basically computer programs that are utilized to edit files on a computer. They provide environment to a programmer to create, edit, update, format a document in any order. In system programming or any other sort of programming, editors are softwares or tools that are used to edit the program. These are basically text editors of special type that have integrated functionality to edit code. Some common program editors are Notepad++, Visual Studio Code, and Sublime. This is very interesting. What happens when a C program is compiled? Let us see. The compilation process in C transforms human readable code, that is high-level language program, into machine language or machine readable format. The compilation process in C involves 4 steps. First is pre-processing, then comes compiling, then assembling, and the last is linking. Once we get an executable file, we are able to see our output on the screen. Look at this diagram. This diagram sequentially will tell us how a program is successfully compiled. So my source code, that is my C program, is first submitted to a processor. Here my processor is nothing but a macro processor whose duty or whose task is to identify if any macros are defined. If any macros are defined, the preprocessor will replace every macro call with its definition, and this is nothing but macro expansion. Thus, because of macro processor, the source code is now converted into an expanded code. This expanded code, which is again in high level language, is submitted to the compiler. The compiler is responsible for converting this high-level language program into assembly code. This assembly code acts as an input to the assembler. The assembler is responsible for converting the assembly code into object code. Along with it, it also assigns symbolic references, or it also assigns relative addresses to various instructions and variables. This object code is then used by the linker. In other words, linker is responsible for combining multiple object files and creating one single object file. The extension of that object file is my exe, or you call it as an executable code. The next diagram is similar to the one on the right, but the diagram on the left is just showing the extension of the intermediate files which are created. In other words, the file which is created after the pre-processing step has an extension .i or .ii. The file that is created after successful compilation has an extension .s. Similarly, after the file is successfully assembled, the file that is created will have an extension .o or .obj, and once the file is linked, the final file which is created will have an extension .exe. Let's see one by one what happens in pre-processing. So pre-processing is the first phase of the compilation process. In this phase, comments are removed from the file. The macros are expanded by macro processor, as I said, and the contents of stdio.h file or any other header files which are written in my program will be copied to this file. A preprocessor is responsible for converting source code into an intermediate file which has an extension .i. Also, it expands our C program containing all the content of header files, macro expansion and conditional compilation. So here just pay attention. When I say that the contents of header files are copied here, for your information, the header files will only have declaration of various functions. We know that whenever we write printf and scanf, we say that these functions are supported by header file stdio.h. So the header files will have function declaration of functions like printf and scanf. The next step, this expanded code is then submitted to the compiler. The compiler is responsible for generating an intermediate code which you call it as an assembly code. This assembly instructions which are created by the assembler are specific to the target process architecture, because we know that every processor has a different way of working. Hence, whatever is the underlying processor, depending on that, the assembly language instructions will be created. This file which is created by compiler will have .s as its extension. This assembly level instructions are then submitted to the assembler. The assembler is responsible for converting the assembly instructions into machine understandable code. Assembler is a pre-written program that translates assembly code into machine code. It takes basic instructions from an assembly code file and converts them into binary or hexadecimal code which is specific to the machine type. The code that is created by the assembler is nothing but my object code. When we work with DOS, the extension of this file will be .obj, and in case if we work with Unix operating system, the extension of the same object file will be .o. Last phase is the linking phase. The linker is responsible for combining all the object files into one exe file. Let us see what the slide says. The last step in the compilation process is linking. Linking is a process of including the library files into our program. So library files means what? The files where the subroutines are defined. All those files will be linked by the linker. The job of a linker is to link the object code of our program with the object code of the library files and other files. The output of the linker is the executable file. The name of the executable file is the same as the source file but differs only in their extension. That is, whether we are executing our program on Windows or we are executing our program on Unix, the executable files extension will be different. Library files are predefined files that contains the definition of library function in the machine language, and these files have an extension of .lib. As I said, when I said library files over here, it basically links the files which has the code of printf. It links the file which has the code of scanf. It links the file which has the code of another functions. So this was the last slide of the module. Here I end my first module. If you have any doubt in the first module videos, please do comment. In case if you require any other videos to be uploaded by me, please let me know. My next video will be on the fifth module of the Mumbai University syllabus of the subject SPCC. Thank you for patience listening.